Okay, we have one more thing to do in this section. We want to talk about comprehensive graphs. So let's talk about what we mean by a comprehensive graphing window. The first thing we want to talk about is a graphing window. This is something that you will see when you start using graphing calculators. If you have it now, fantastic. If not, you will probably use one in a future math class. You do not need a graphing calculator in order to talk about graphing in a comprehensive graphing window. So a graphing window, what it does is it identifies the range of values for the x and y axes. When we talk about the x-axis, we want to know how far left do we need to go and how far right do we need to go. And for the y-axis, how far down and how far up do we go. A comprehensive graph, this is a graph that identifies all key points for a particular equation. When we talk about linear equations, which is what we're looking at right now, the first thing that we need is x-intercepts and y-intercepts. As we progress to other types of equations, there will be more things to be included. So, if you've already done the homework, you've probably seen a notation where you have 4 numbers inside a set of square brackets. So let's talk about what each number means. The first 2 are the numbers that are associated with your x-axes. These are the x minimum, or the leftmost value, and the x maximum, or the rightmost value. The second 2 numbers deal with your y-axis. They are the y minimum, or the bottommost number, and the y maximum, or your topmost number. So what we're going to do in this presentation is we're going to talk about what would be a good graphing window. And the main thing we want to keep in mind is that we are able to see our x-intercepts and our y-intercepts, and that it's not too big to where we wouldn't be able to identify the points. So, for the following equation, we want to determine which of the graphing windows will show both intercepts. So the first thing we want to do is we need to find our intercepts. If we look at f of x equals negative 15x plus 50, I'm going to change it over to a y, just to make sure that, remember that f of x and y are the same thing. The first thing I want is my y-intercept. We don't have to do any work for this. My y-intercept, remember, is the second number, so it's going to be 0, 50. Now for my x-intercept, I do need to do a little bit of work. Remember that to find x-intercept, we're going to plug 0 in for our other variable, so I'm going to plug it in for the y. And then I want to solve for x, so I'm going to subtract 50. We get negative 50 equals negative 15x, and then we divide by negative 15. If we do this, I come up with 3.33, repeating, but basically somewhere around 3. So my x-intercept is 3.3, 0. Okay, so let's go ahead and look at each one of these graphing windows and determine which one would be best. Now the first one, just to let you know, when you start using a graphing calculator, we call this the standard window. Negative 10 to 10 on our x-axis and negative 10 to 10 on our y-axis. But a standard window is not necessarily going to be a good window for every single equation. And the question is, does it work for this? So 3.3, let's start with our x-intercept. Is that between negative 10 and 10? The answer is yes. Okay, let's check our y-intercept. 0, 50. Is 50 between negative 10 and 10? The answer is no. So this is not a good window. If we look at example B, again, my x-intercept, 3.3, is it between negative 5 and 5? The answer is yes. 0, 50, is it between negative 20 and 80? Yes. This would be a good window. If you do the same thing for C and D, we do run into issues. 50 is not between negative 10 and 10, so this would not be a good viewing window. Also, negative 60 to 60 would not be good for the 3.3 just because it's a little too big. It's actually a lot too big. We won't really be able to see our x-intercept clearly. In example D, negative 10, 0, 3.3 is not between negative 10 and 0, and so that would not be a good window either. So our best bet is example B. This is going to show us both the x and the y-intercepts, and it's not too big. All right, let's try another example just to make sure that we have it. Example 2, we have g of x equals 0.2x plus 40. So again, I'm going to replace g of x with y just because I can. So if we start with our y-intercept, again, we don't have to do any work for this. It's going to be our second number, so it's going to be 0, 40. Our x-intercept, we do need to do some work for that, so I'm going to replace y with 0. And I'm going to solve for x. So I'm going to start by subtracting 40. We get negative 40 equals 0.2x. And if we divide by 0.2, I get negative 200. So my x-intercept is negative 200, 0. Okay, so let's go ahead and look at each one of these. Is our standard viewing window a good option? No, this is not going to show us our x-intercept or our y-intercept. Negative 200 is not between negative 10 and 10. And same thing with 40, it is not between negative 10 and 10. In fact, I don't think we'd see anything if we graphed using this window. All right, example B. Negative 200 is not between negative 50 and 50. And 40, I think this is going to be a little too big in order to see 40. So B is not a good option either. Same thing with C. Negative 200 is not between negative 5 and 5, so we would not be able to see an x-intercept. That leaves us with D. Is D going to be a good window? And so for D, negative 200, is it between negative 500 and 500? The answer is yes. 40, is it between negative 50 and 50? Yes, it is. And so example D is going to be our comprehensive graphing window. Now, as we progress through other types of equations, this might come up, or you might have to wait until the next math class to talk about comprehensive graphing windows in more detail. But you want to make sure that you always have x and y intercepts when you talk about comprehensive graphing windows. No matter what type of equation you're working with, those two are always going to be needed. As you get into more complicated equations, if you recall vertex for quadratic equations, that's another thing that will be added on. And so we might see that later this semester. All right, that takes care of A.8. So now you should be able to go ahead and do the homework if you have not finished it yet.